Good morning, everybody.
Today is Friday, June 19th, your last day of geometry class. Today's lesson, I think, is really fun. Again, it's usually using visualization techniques to be able to determine the surface area of various three-dimensional shapes.
Let's kind of talk about this word right here. This word is important. Surface area. Two different words. Surface means on the outside, all the space on the outside, and it says area. So now hold on, step back. If we talk about area, we have to talk about the square units on the outside of this 3D shape. So that's actually why we start this lesson talking about the net space. The net space for a three-dimensional object is as if I take, when I get my shipments from Amazon, I don't like to keep those boxes like fully as a box so they could fit in the garbage. I actually take it fully apart. And that's the idea, is if I take a box and I flatten it on the ground, what shapes does it consist of? And that's what surface area is. And that's what the net space is which one of these, so if I look at number one, which one of these three net spaces is specifically for the shape? So it should go by pretty quick because you could tell yourself, hey, wait, I know this is a cone. A cone has one circular base. So in my net space, I should only have one circle and something that's somewhat triangular. So if you look at your choices,
you could see that A has one circle, and if I were to cut that cone triangular piece, if I were to cut it down the middle and flatten it out, it would actually look like what you see in A. Very cool. You'll notice that pattern makers would use this type of visualization, this type of geometrical math.
That and also origami. You need to know what shapes you need to create, certain shapes when you're playing with origami. Number two, some of you can recognize, hey, wait, I have two congruent triangles. That means I have a prism. So in my net space, I should only have two congruent triangles. And then the remaining part should be these lateral faces, which are the three rectangles. So the only one that has that is
choice B. Notice she said three rectangles. One is the base and two are the sides.
And the two triangles are the two congruent bases. The other three rectangles, when Miss Murphy said base, she meant bottom. But the other three rectangles are the lateral faces. Let's look at number three. So notice they all meet at a point. So this is a pyramid. So if I'm looking at a pyramid and the base is a 1, 2, 3, 4, 5. So I'm looking for
a
pentagon. So that means my faces are, my lateral faces are triangles. So I should have 5 triangles and a pentagon. So 1, 2, 3, 4, 5 triangles and a pentagon.
Ooh, a cylinder, number 4. We know that a cylinder is made up of two circular bases. And if we cut open the middle and laid it flat, it would roll out to be a rectangle. So choice C.
The way you could think about that rectangle is think about when you have a water bottle and you take off the label and you flatten up that label, you'll have a rectangle.
Perfect. That's a good way to explain it.
This next one meets at a point, therefore it is
also a pyramid
with one square or rectangular base and then 4 lateral faces of triangles. So 4 triangles and a rectangle or a square.
So choice B. Ooh, I see 2 hexagons in number 6.
So that means we have a prism. So I should have 2 hexagons. And my lateral faces are all rectangles. Since I have 6 sides, I should have 6 rectangles. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So this is not it. 1, 2, 3, 4, 5. That's not it. 1, 2, 3, 4, 5, 6. So 2 hexagons. And 1, 2, 3, 4, 5, 6 rectangles or squares, whatever it may be.
Wow.
And then this last one looks like a cube or a prism where I should have 2 bases that are exactly the same. It could have been top, bottom, left, right in this particular example.
And I'm thinking of dice here. How many sides are on a die?
So you should have a total of 6 rectangles here, or squares if this is a cube. So this is my 6 cubes here. It's very,
Excellent.
very, very cool, Miss Murphy. If you actually print any of these out, if you print it, if you enlarge it and print it out on a piece of paper, you can make these 3-dimensional shapes.
You can fold them up and tape them and create exactly what you see on the left.
Absolutely.
That would be a fun activity if you're bored. Okay, so now let's apply some of these principles to word problems. We'll do these word problems with you since we know that they're not always everyone's favorite, but let's take it as a challenge. Number 1, how many more, sounds like we're comparing here, how many more inches of cardboard does a cube-shaped box with a side length of 8 inches have than a cube-shaped box with a side length of 4 inches? Are you able to draw a cube yet? It's a square that has volume.
So watch this. I'm actually going to draw 2 of them that are congruent and then just connect the corners.
And there you have a 3D cube. So the first cube has a side length of 8 inches. And the second cube has a side length of 4 inches. Since we're comparing these, how many more inches does the larger have than the smaller? We would need to subtract the 2 volumes. So if you remember the volume of a cube, what's the formula for the volume of a cube? It's 3-dimensional, so you need 3 shapes. So you thinking of something?
Yes, Miss Murphy, I am thinking. So you're finding volume. Now, when you have a cardboard box, is the whole entire inside and everything made out of the cardboard?
No, it's not. So this lesson is about surface area,
Right?
not volume. So how many more inches of cardboard? So again, think of Mrs. Talhami's example of when she gets an Amazon box in the mail and she flattens it out. The Amazon box, when she's done taking out the contents, is empty. So really we're finding surface area.
So let's just focus, since a cube has all the sides the same, 8 by 8 by 8 by 8, we only have to do the area of one of the sides and multiply it by 6 here.
That's right, because we have 6 sides. So 8 times 8.
6 times the 8 times 8.
So 8 times 8 is 64. And 6 times 64 is 384.
6 times 64. Oh, wow. 384. Very good. So this has 384. Now, this is inches what, though, if I found the surface area?
So area is always squared. Volume is cubed. So we're going to do the exact same thing for the smaller cube. So it's going to be 6 times 4 times 4. 4 times 4 is 16. And 16 times 6 is 96.
So the final surface area is 96, Miss Murphy?
96 square inches.
Great.
So we'll go back to the question. It wants to know how much more does the first cube have than the second. So how much larger is 384 than 96? 384 minus 96 is 288 square inches.
So that's how much more cardboard is needed when you're making an 8 side length cube box versus a 4-inch side length of cubed box. I think that was not English, but that's okay.
I was following you completely. Yes.
Which is something that you actually discussed, if you remember a few lessons back. You said this is important for people who actually their job is to ship things out. It costs them much more money to make a bigger box than it does to make a smaller box. So that's why they try and ship things as much as they can and fit them into smaller boxes.
Okay. Ooh, question number 2 sounds interesting. The outside of a pharaoh's casket, like you would find in Egypt, in the pyramid, will be painted 10 by 2 by 2. Can you draw a casket? So if I had to draw a casket, I would draw it as a rectangular prism. Again, rectangle has 2 squares, and when you connect the corners, there we go.
The only reason why I knew to draw squares because they said 2 by 2. So
Yes.
That's the reason why I started out with the 2 squares here.
Which is really not what King Tut was buried in, but we'll take it.
So this is a 2 by 2 by 10. Yeah, he was buried in something much more fancier than that kind of casket. That's like old school, cheapest kind of casket I can get here.
So again, let's not make the mistake of thinking that we're finding volume. We're not going to multiply 2 times 2 times 10 because we're painting the casket. When you paint something, you're painting the outside, so that's surface area.
So you know what I like to think, Miss Murphy? I like to just start with like the bottom and the top, because I know those are the same in this picture. So I'm going to say the bottom and the top. What are their dimensions?
So we have a 2 by 10 rectangle.
So if I have a 2 by 10, I have 2 of those. So I'm going to multiply that by 2. So 2 times 10 is 20, times 2 is 40. So far I have 40 square feet. Then I want to discuss maybe the left and the right one.
And those happen to be the same measurements, Mrs. Talhami. Those are also 2 by 10. So if we do the math, we'll end up with another 40 square feet.
And then let's do the front and the back. So the front and the back
front is a square.
Are just the 2 by 2s.
That's right. 2 times 2 is 4, times 2 is 8.
So then my total volume, surface area here would be
88.
88, and then it says, since we're talking about feet, this is square feet.
Square feet.
That's
how much paint you would need.
Exactly.
And you can figure out how much you have to order if you go to Ace Hardware or Home Depot or A-Box based on that number. Every gallon of paint can cover a certain amount of surface area.
Absolutely. And that actually, I'm not lying, Miss Murphy. I'm going to let you know, when I had to paint my house, when I first bought my house, yes. I actually had to, I didn't measure to the T, but I had an approximate, square footage of how much surface area I needed to cover. I went to the paint store, and the guy was pretty accurate about how many cans I needed for each room.
Excellent. They're probably so happy when you come in with knowledge of what you're trying to accomplish. Yes. Makes their job much easier.
For sure.
So number 3, we are actually going to give you a new formula because we did not yet discuss the surface area of a sphere. So think if you had to cover a ball or a globe. And in this case, they are talking about the Earth. The Earth is not a perfect sphere because its radius varies depending where you measure it.
Did you know that?
I actually did not know that,
Mm-hmm.
but I would assume that it cannot be a perfect sphere.
So
Assume, however, that the radius is 4,000 miles. What is the surface area of the Earth? Use 3.14 for pi and round to the nearest square mile. Okay, so our unit measure here is square miles. I do know, Mrs. Talhami, that 75% of the surface of the Earth is covered by water.
Yes, I did know that too.
Which is quite amazing. So the radius is 4,000 miles. And our formula is 4. And they told us to use 3.14 for pi. So it's 4 times 3.14 times 4,000 squared.
This looks like it's going to be a big number.
Yes, it does. Well, the Earth is pretty big. And it would help if I turned my calculator on before I try to put this in. Okay, I'm getting, ready for this number? First we'll read the numbers and then we'll try to read it properly. 200960000.
Oh boy.
So let's go from the back and count 3 for each comma. And I know if I have 2 commas, I have to start with the word million. So we have 200,960,000 square miles of surface area on the Earth. Very cool. Number 4, a can is 4 inches wide and 8 inches tall. Let's start by drawing a cylinder because we know a can, Campbell's soup can, is a cylinder. It's 4 inches wide, meaning that that's the diameter. If the diameter is 4, the radius is going to be 2.
Look at Miss Murphy already thinking ahead, huh?
Trying here. And our height is 8. To the nearest whole number, so no decimals in our answer, what is the area of the label that wraps around the can if the label is 3 inches shorter than the height of the can?
So look at this.
Use
I'm going to hide.
3.14 again for pi. And I love, Mrs. Talhami, your example before. Think how many times you take the label off your water bottle.
Yeah, right?
We used to collect Campbell's soup labels and mail them in, much like box tops. And you would get credit for school.
Oh, yeah?
Yes. So if you go downstairs and you take a can out of your pantry, take off the label and roll it out, you'll see that it makes a rectangle.
Do you know that they actually have the cans now? All the soda cans have that like Six Flags and the Six Flags coupon. Yeah.
I wonder if they're opening up Six Flags.
Oh.
Maybe slowly like Disney with certain precautions.
Yeah, right? So I want us to really focus on something they told us, Miss Murphy. It was really important that you stressed it while you were reading. They want the surface area of just the label. But it says the label is 3 inches shorter than the height of the can. So if it's 3 inches shorter, what does that mean this height is?
So that must be 8 minus 3, which is 5.
Okay, so very important to notice that it's 3 inches shorter. And then you said before that means also our radius is 2. Now, if I just want the label, Miss Murphy said we take off the label and I spread it out, and this is the shape I now have, right? So this part is the 5 inches we're talking about. But what represents this piece right here?
So we really need to go all the way around.
Think about that. That's this piece right here. You see how I'm darkening it in? That's this right here. What part of the circle is that?
The circumference?
It is. So this is the circumference of the circle. So since this part is the circumference, we know circumference equals pi times diameter. So pi times my diameter, the whole thing we said is 4. But it says here use 3.14 for pi. So I'm actually going to erase this pi and I'm going to replace it with 3.14. So
3.14 times 4 is 12.56. And I'm trying to find the surface area of the rectangle, which is length times width. So 12.56 times 5 is 62.8.
You said 62.8?
Correct. But I noticed, Mrs. Talhami, you put a nice cloud around the directions. They wanted to the nearest whole number. So 62.8, if we round that up, will be 63. And our unit measure is inches squared. Very cool. Lastly, number 5, the diagram shows a pattern to make a camping tent in the shape of a square pyramid.
There's no diagram, but I'll draw the diagram.
And I know Mrs. Talhami, whenever she's talking about a pyramid, it is always referring to a common point that they are all attached to. If the triangular panels are 8 feet wide and 6 feet tall, how much material will it take to make the tent, including the base? So again, real life application, tent makers. Nice thing to do this summer, go camping.
So it said the triangular panel is 8 feet wide. So here's a triangle that's 8 feet wide. And then it says it's also 6 feet tall, right?
That's right. So you need to make a perpendicular altitude.
So how many of those panels do we have?
Well, we have 4 since it's a square pyramid. So we actually have 4 triangles.
So the 4 triangles, and this is nice. The area of a triangle is 1/2 base times height.
So half of 8 is 4. 4 times 6 is 24. And 4 times 24 is 96.
So far the 4 triangles are 96. And then if I worry about this base, that's a square base. It says it right here. It says it's a square pyramid.
So that must mean all the sides are the same. So 8 times 8. Don't use that 6. Don't be tricked. 8 times 8 is 64. And if we add those two together, 96 plus 64, we will get 160 square feet. Every time we're talking about area, it's always square feet squared. That's how much material it's going to take to make that tent.
So surface area is not that simple. It's really hard because you have to visualize now not only the 3-dimensional piece, but now taking it apart and flattening it and figuring out what shapes it consists of. I'm not speaking English today, Miss Murphy. But really, what I want you guys to think about when you're doing surface area problems is to think back when we first discussed 3-dimensional shapes. When we mentioned a prism, we have 2 congruent shapes, and the lateral faces are all rectangles. When we talked about a pyramid, we said 1 base, and then all meeting to a point, so all the lateral faces are triangles. So these are things you have to constantly repeat to yourself and picture when you're talking about 3-dimensional shapes and their surface areas.
Okay, and that concludes your geometry course. Thank you to all of those students who worked through the videos, did their lessons and assignments. these lessons never leave you. They will help you as you continue on in your math career, in your real careers, and getting into college, things like that. All the work along the way adds up. So kudos to you for all of your due diligence. Mrs. Talhami and I wish you the happiest of summers, and I hope that you will come and visit us next year. We'll be in the same classroom together as a team again.
And I do miss you guys. I really wish we were in class to celebrate the end of the year together. So I do hope you guys have a great time. And like Miss Murphy said, I really hope you come visit because, we abruptly left and we both definitely miss you all.
Take care. We wish you the best. We're always here for you. Bye.
Bye.